In this problem, our goal is to estimate for the true or the actual proportion value of the entire population. The population that we're referring to here is all children ages 2 to 11 who drink sugary drinks. So we want to know what that true percentage is. In order for us to estimate for this percentage with 90% confidence and also be within a margin of error of 3%, meaning I want to estimate for the true proportion value with 90% confidence and not be wrong by more than 3%. I have to ask myself, how large of a sample would I need? So how many children between the ages of 2 and 11 do I need to survey and then ask the question, do you drink sugary drinks? Yes or no? So how many children do I need to survey so that I can estimate for P with 90% confidence and not be off by more than 3%? There is a formula for calculating N, and which formula we use depends on whether or not we have some sample data to work with. So before we can calculate N, we need to ask ourselves, has there been a previous study that's been done that's similar to this question that we're trying to answer? Is there a sample proportion value where we have a percentage of children in this age range who drink sugary drinks from a sample or that's been done? And in this problem, the answer is no. We don't have this value. It is unknown because as I read this problem, nowhere in here am I given any information of a similar study that has been done where I have a p hat value. So in this situation, anytime that p hat is unknown, we typically use a conservative value of 50%. So converting that to its decimal equivalency, that's 0.5. And then that means 1 minus p hat, or the complement, which we call q hat, is going to be the other 50%. So here, using those conservative values, the formula is you take the critical value that's associated with 90% confidence level. We square it and we multiply it by the conservative p hat value and the conservative q hat value. And we divide this by the square of our margin of error. So don't forget to convert that margin of error to its decimal equivalency. And we're going to square that. So before I can get the final answer, I need to figure out what this critical value is. So that critical value, z sub alpha divided by 2, is a z-score on the standard normal distribution where the mean is 0 and the standard deviation value is 1. And it's the z-score that separates an area of alpha divided by 2 on the right. So let's ask ourselves what alpha is. Alpha is your confidence level. Let's go ahead and write that as a decimal. Minus, hold on, let me rewrite this. Alpha is 1 minus your confidence level. So that gives me an area of 10% or 0.10 on the right, and then I'm going to divide that by 2, so divide it by 2, which is the same thing as 0.05. So on this bell-shaped curve that I drew at the bottom here, this standard normal distribution, the area that I'm shading in red there is an area of 0.05, so that's 0.10 divided by 2. And we know that critical values usually hover around 2. So here, this is where you would go to your calculator and use inverse norm and type in 1 minus the area on the right, comma 0, comma 1, and it's going to give us a critical value of 1.64. So a z-score of 1.64 is the z-score that separates that area of 5% on the right. And now that's what I'm going to plug in for this value here. So if you take all of this and put it into your calculator, 1.64 squared times 0.5 times 0.5 divided by the square of 0.03, we should get a sample size of 7.11, which we can round up to 700 or round down to 747. So I would need to survey at least 747 children in order to estimate for the true value with 90% confidence and not miss the true value by more than 3%.